Yeah, absolutely. We'll have time to look at different stuff. All right, so what would you like to ask or review with regard to a lab? And I'm assuming you're talking about the microscope and the dissection.
Uh,
You tell
yeah,
me.
so are those going to be on the quiz tomorrow, or was the microscope like 4?
Well, I just showed you you have the syllabus there.
Yeah, so it's on 5, 6, and 7.
That's what we're doing tomorrow, right?
Oh, okay.
But last week, we had a quiz over the preceding week's stuff, anatomical terminology and so on. But we did the microscope and the rat dissection. So the microscope and the rat dissection are going to be the majority of points on tomorrow's quiz.
Okay.
But I said that you could see a question related to the exercises that we're doing the day of the quiz.
Okay.
Hence, I focused and emphasized the materials and methods of exercise 6.
Okay. I just think I'm keep reading this wrong. And then so I printed out the new one that you sent in the email. So should I just get rid of the other one completely?
Yes. Yes. Get rid of the last, I don't know, 3 pages. I would say everything else is the same. It's the lecture schedule and the lab schedules that I adjusted a little bit, and mostly the lecture schedule where I listed like 10 quizzes. We're only having 5 lecture quizzes.
Okay.
So again, let me share the screen. There's the updated lecture schedule. This is the one I sent you recently. I updated and I took a lot of the quizzes that were in this column out. There were 10 of them there. And that's because this was from spring 2020 when we met face to face, and I gave 10 lecture quizzes. So I cut down on that number. And that's what you got now in front of you. You got the updated 5 lecture quiz dates right here. So those lecture quiz dates I have on the lab schedule as the yellow highlighted areas. So we had one last week. Here's quiz 1, lecture quiz 1 on the 3rd. We've got our second lecture quiz on the 3rd of March. We've got our third lecture quiz on the 17th of March, and so on and so forth. So there's 5 of those listed. Here's the last one, April 21st. Lecture quiz. The lab quizzes, which I've indicated with the red asterisk that's highlighted in green, right? This says lab quiz. We have a lab quiz tomorrow, and that lab quiz is going to be over primarily what we did the preceding week, which is scope and dissection. And you could see a question from these. And I told you, read 6. Next Wednesday, is there a lab quiz? No. Is there a lecture quiz? No. There is the first lecture exam, and we're going to talk about that this week. So that's a biggie next week. The first lecture exam is going to be in lab on the 17th of February. And we're also going to do exercise 8, lab exercise 8, after the test. Does that make sense? How to read this? You're muted. Sadie.
Yeah, I got it now. Thank you.
Okay. If it's still confusing, ask. You know what's going on here. Okay, so what do you want to ask about with respect to the lab? You said you wanted to look at lab stuff. So I'm assuming you mean microscope and dissection, because we have a quiz over that tomorrow. Anything you want to specifically ask about in terms of the lab exercises?
So for like the microscope, I'm gonna guess like we just need to like know the parts and stuff. And I have that down pretty well.
Okay.
So for the rat, is there like, is it gonna be close to like a diagram? We gotta like show what it is, or
Okay, so for that exercise of the dissection, I could do a couple things. I could have a rat sitting out and at a, we'll call it station number 1, up in front of the room. I'll have potentially have a dissecting tray with a rat in it. I could, with a pin pointing to the stomach and asking you identify the organ shown and what system it belongs to. And you say stomach, digestive. I could have a pin in the kidney and ask the same pair of questions. So you could potentially, theoretically, have the physical specimen there with a question or two on it. You could also potentially have one of those diagrams that we referred to last week. Remember the handout from Blackboard you brought, and you used those as I was showing you the dissection. You were comparing your handout to the screen, which we're seeing on the screen. That could be, that diagram could be on quiz. And obviously, you know, whether you study the diagram or you have the dissected specimen, you got to study the organs. So you should be looking at those sheets. I could also ask you a question that doesn't even require a specimen or a diagram. I could say, fill in the blank. The blanks convey urine from the kidneys to the blank. You say ureters and urinary bladder. So that doesn't require you to see the rat. It requires that you understand what the ureters are and what they do. And we talked about all of that. So I'm hoping that you guys were taking some notes or making some, you know, I hope you were taking notes or mentally noting what I was talking about when I did the dissection. I wasn't doing that just for the fun of it, you know. Although I do have fun. I love doing dissection. But, you know, you guys have to, you got to learn what I'm talking about. So if I talked about, you know, what is a mesentery? What's the mesentery do? Or if I reference the liver in helping to detoxify drugs, or if I mention the stomach is where alcohol is absorbed, and that's why on an empty stomach or even on a full stomach, after having an alcoholic beverage, you feel kind of woozy. It gets absorbed much quicker than most materials do. I talked about that, so that's certainly worth noting. There is also that rat in the plexiglass container, remember, that I showed you up in front? That's always in there. So you could come today if you wanted to, because the lab's open on Tuesdays, right? And it's up there. It's in there. The scope is here. The slides are here. If you want to come in and look at the scope again, look at the parts. The room's open. Tuesdays, the room's open. I'm not saying you have to or should, but if you want to, you can. That's why we made arrangements to have that room open for you.
I don't have to go and sign in like tomorrow when we show up. Do we have to be tested again every time we have to go to that little booth every day or every time?
I think they're having you check in at that table for, like, this may be the last week they're doing that. And get the bracelet.
Yeah.
I think they're going to discontinue that. That's not going to go the entire semester. But don't you have to load an app on your phone and report in? Beth, you're muted.
I have to load an
Yeah,
app.
there's an app that you have to, I'll send it to you, John.
And why do I need to do that?
Because then you don't have to sign in, she said. She said if you put this app on your phone, here's the paper, but I'll take a picture and send it to you.
Well, Katie has it and Beth has it, and that's because they sent it, the college sent that email to you?
Oh, last week when we went and signed in, she gave this to me.
Oh. And Sadie, where'd you get yours?
But she
How
ran
did the-
out. She ran out when I went and he came after me. So that's probably why he didn't get one.
Where'd you get it, Sadie?
I got it from the table at
Oh,
the
you did too.
center.
Okay.
Yeah, because she didn't offer me one, so. Yeah, if she'd had them, she would have offered it.
Yeah, I
Well,
got the last one.
Isn't the college communicating to you guys what needs to happen in terms of pool testing or what have you?
Yeah. Yeah, I remembered at the last minute I was supposed to go and get that.
Well, you got to stay on top of that sort of stuff.
Yeah.
They do the pool testing like twice a week, I think Tuesdays and Wednesdays, if I recall. Yeah, it's pretty important to do. Okay, so anyway, back to microscope stuff. You should know the parts of the scope. You should know how to focus. We talked about the steps that you should follow. We talked about how you customize the scope using the left diopter ring. Remember, we described that process of how to adjust that so that when you look through the scope, you see clearly with both eyes, right? There are some questions in the back in the lab report. For example, the part D assessments, there's some matching questions that would be maybe helpful to do.
In the back of the book, in the back of the lab book?
In the back of the exercise 4.
Oh, in the back.
Remember we talked about how every exercise has a lab report associated with it? Here's the one for exercise 4.
Hold on, wait.
And I said, if you want to check your answers, how do you do that? 2 ways to check your answers,
You have all the answers on Blackboard.
right? And the other way to check your answers is in the room. I've got those folders in the front and in the back. Yep.
I just printed it out.
So the,
So
the answers to these?
Yeah.
Are in those folders.
John, you must have been sleeping when I said that.
Or I was thinking about statistics.
Square root of 4 is 2. Oh no, that's not statistics. Yeah, in the back of the room and in the front, there are red and blue colored paper folder binder type things.
Oh, and at the school, yeah, I remember, yeah.
Yeah, in the room. That's what I said, in our classroom.
Yeah.
There are these, and they're labeled exercise 4, figure answers and lab report answers. So you can check those anytime you're in that room.
For the answers in this book.
Yes.
Oh my goodness. Then
And as Sadie
I remember you saying that.
As Sadie correctly said, the answers are also on Blackboard. You can
Right.
also check them from where you're sitting right now if you want.
Yeah.
'Cause she's printed them off. She's killed like 10 trees doing that.
You should see my chemistry that I printed out. I printed out one of his lecture slides. It was like 40 pages.
Really?
Yeah, I couldn't even staple it. It wouldn't go through.
She's an industrial stapler. Yeah.
So where's the lab folder in Blackboard?
Okay.
I see the stuff to bring to class every week.
All right.
Stuff to bring to class or lab every week. So
Hang on.
I thought I've been through all of these folders already. I literally have I have a desktop and a laptop that I work with just to get through homework.
Mhm. Okay, so you go to content.
Yep, I'm in there.
I think it is stuff to copy and bring to lab each week. I think it's in there. Right here, answers to lab report questions from lab manual.
Uh,
Do you see that?
It's got 2 through
Now-
4.
Now, John, how can I title that more expressly?
Okay, are you guys laughing at me right now? I don't understand.
You click on that, John, and then it says exercises 2, 1, 10,
Okay, I got it now.
and there they are.
You know what? And I've been through. I saw
I
those.
can't.
I saw those, and I still didn't catch on that that was what that was for.
Yeah. That's what it is.
Yeah.
So they're all
They're
there.
in fucking jail. What? I mean,
They're
they
all
can't
there.
hear me.
Yes, we can. Yeah, you just had a moment.
Yes, you did.
You had
They
a
see
moment,
you.
Beth.
And you're going to be put on Facebook. I just want you to know that. It's going to be on Facebook. No, it won't. But I am recording these because if somebody in review wants to come and see what we discussed, they've got to be able to do that. So be
Yeah, I
careful
got it,
when you're
man. I got
muted
it
or
figured out now.
non-muted.
They can hear me.
Okay, so everybody clear on that? At least, John, you're good with it, right?
Yeah.
Okay.
Yeah.
All right. How about other questions? Anything on the microscope or the dissection you'd like to talk about or review?
So a lot of this stuff I already had because I've been reading it. So I got the right answer, so that's good. It's just that when I get in class, I need to show up with the right answer.
That helps.
Yeah.
All right. So any questions on the lab? Okay. How about questions on the chemistry chapter? Because there is
Yeah.
this little quiz coming up. Beth's got a question.
Well, I'm definitely like the rat dissection and the microscope, I feel pretty good about, but the chemistry,
Yeah.
I'm a little nervous about that one. So
All right. So as you read through the chapter and as you maybe referenced the chapter 2 PowerPoints, or maybe you met with Kyra Sunday night, you remember she had that review. What parts of that chapter would you like to review? We can pull up the slide, we can talk about it. We've done that in the past. What's causing you a lot of issues? Don't say the whole chapter.
I don't know specifically. I guess I'll have let me get back to you. Let me look
So
and
this is
see
what you got.
exactly.
This is your assignment, okay? When you
Okay.
guys have review like we're having, you have to come with questions. You gotta say,
Okay.
I want to go over the section in chapter 2 on organic molecules or whatever. That's when you study at home, you got to make a note, take a little stick-it note, say, ask about blah, 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 and then bring your note today. Because
Okay.
we're just spinning wheels, wasting our time unless you guys have questions. I'm not trying to be picky, but right, you got to give me some guidance. You
Yeah.
got to tell me what's the problem? What's causing your problems?
You're not being
Covalent bonds,
picky.
like
You're not being
covalent
picky.
bonds.
Okay, hang on, John, hang on. Let me ask Beth because she brought up the chemistry chapter.
Okay.
Is there a specific part there that you'd like to review?
Just no. Like I'll get back to you. Just go
Okay.
with John's question
Okay,
and
okay.
I'm just gonna look, and you're right. I'm sorry. I wasn't prepared. I will be from now on.
No,
You're not being picky. I
No,
understand.
I'm not trying to pick on you, Beth. I
No,
really
you're
am not. Okay, don't take it that way.
oh my gosh, I do not have thin skin. Don't worry. You
No,
can
I'm
pick
not,
on me.
I'm not trying to be a pain.
No, you're not.
I just want you guys to come with questions, right?
Okay.
And see that we can make the best use of our time. So, John, you were asking about covalent bonds?
Yep, covalent bonds, and there's that third one. Bonds, covalent
Hydrogen
bonds.
bonds?
Yes,
Okay,
can we go over those? Those are
He has,
gonna be, those, what's that?
he has a chart in the lecture that has like all of them on it, and it has like definition, description, and example. I found that was really helpful to study.
That chart right there?
Yeah, it's at like the end of the lecture slides.
Okay,
okay. Do you guys see the chemistry
yeah,
2 PowerPoint? You're saying at the end of the, where do you mean?
Oh, I must have been looking at a different lecture. Like, you had it like all like typed out.
I don't know. I'm drawing a blank as to what you're referring to.
Hey, John, did you get the email from Sunday night? She gave us like a list of things to study.
yes, I got it.
Because I got that and that's what I've been kind of using to
Good.
study. Like it says a lot of things about like covalent bonds. Like for instance, like distinguish between a single covalent bond and a
Okay.
double.
Okay,
So if you look in the book, I found a single covalent bond is 2 electrons shared, and then a double is 4 electrons, if that's kind of,
yep, it does.
yeah. And then even the same with explain how a hydrogen bond forms the positive hydrogen end of a polar molecule to a negative, whether it's nitrogen, oxygen, and end of a polar molecule, if that
Okay.
makes sense.
It
But
makes, yeah, I'm reading it right out of the book.
Okay,
Okay.
let's talk about the difference between the three. With regard to ionic bonds, we described this last week, I think.
Hmm.
Do you remember this?
Yep.
We said that in the case of an ionic bond forming, you've got to have the transfer of valence electrons from one element or atom to another element or atom. We used the example between sodium and chlorine, these two atoms. You have to understand several things here. One thing you have to understand is how many valence electrons you find in the first, second, and third energy levels. You have to kind of just memorize this.
Mhm.
The first energy level can hold a maximum of 2. The second and third can hold a maximum of 8. We won't go beyond the third, but there can be more energy levels depending upon how complex the atomic structure is of the element. We're going to just stick to 3. So look at the sodium atom here and look at the chlorine atom. Before they interacted with one another, what was the number of valence electrons in a sodium atom? This electron goes there. So put that back here. Before they interact with one another, there's 1. There's 1 valence electron in a sodium atom. Because the first 2 are filled with 2 and 8 respectively, and the last spot, the only spot that this last one can go to is in the third. Okay, because these other 2 are filled.
Mhm.
Everybody buy that?
Yep.
Okay, how about chlorine? Well, how many valence electrons in its outermost shell?
8.
8. No.
Wait.
How do you get 8? 1, 2, 3, 4, 5, 6, 7.
Or 7, yeah, but when it transfers.
No,
in.
no, we're not doing that yet.
Okay,
I'm just saying as it sits there on the periodic chart, chlorine atom has 7 outermost valence electrons. Sodium has 1 outermost valence electron. Okay. Now, how many would sodium like to get, if it could, to fill its outermost shell, which would be stable? It has 1. How many do you need to get to 8?
7.
Right, you need 7 more. It would love to get 7 if it could, but it's not going to get 7. It just can't get 7. How many would chlorine like to have?
8.
Yeah, it's got 7 now. It needs how many more?
8.
1.
1.
Right.
Okay.
So you see what's going on here? Sodium says, I will transfer, I will donate my valence electron to you. You will then have 8 in your third shell. You will be chemically stable. You will be a happy, smiley face chlorine atom. Okay? How about sodium? Well, what's going to happen to sodium? There he goes, transfers it over. What happens then? Drops down to its second shell. How many electrons?
11.
In the second shell?
Wait, none. It's none. In the
8.
second shell.
8. 8.
I keep it's the outer, it's the rings that I keep getting confused with.
Yeah. This is the first, this is the second, this is
Second and
the
then the
third.
third.
If it gets rid of its outermost valence electron in the third shell, it drops down to the second, which is full. What does that mean? That means this is a stable
Stable.
situation. So sodium's happy now that it's got a full, stable outermost shell with the 8. What this creates then is a charge difference between the two ions
Okay.
as it creates this sodium chloride compound. This is salt, sodium chloride. The sodium end gets a +1 and the chloride end gets a -1. Well, why does that happen? What's the plus and minus mean? Do you remember?
Mm.
When it gains an electron and when it loses one. So if
Right.
it loses one, it becomes stable, so it's a positive, because like the protons and the electrons are uneven, so it's just plus
Oh
one.
yeah, I see it now.
How many plus charges are here on this sodium ion?
10.
Plus charges?
It's
Well,
11.
It says right there,
11.
11.
Yeah, I just didn't know if you meant like after it lost.
Plus 1 to make it stable. So that 1 made it stable.
No. When it gave the electron away, that didn't change the positive charge,
No.
right? This is
Oh,
negatively charged.
Mhm.
So the plus charges stay at 11 all the time. That doesn't change. But how many minus charges does it have? 2 plus 8,
8 is 10.
right? So do the math. 11 pluses, 10 minuses gives you a +1. How about the chloride end? How many plus charges? 17 protons. How many electrons do we have? 2 plus 8 plus 8.
17.
18.
18. Yeah, so I meant.
18 minus charges, 17 plus charges, the net difference is a -1. This -1 comes from having acquired that outermost electron. So big deal, you say. Why do we need to know this? What's the significance of having a plus charge on one end and a minus charge on the other end? Well, that's pretty darn important, because when you look at sodium chloride, the crystal, if you could zoom in with a special type of microscope, you would find that wherever you have a negatively charged chloride ion, it's surrounded by positively charged sodiums, because unlike charges attract. Another way of saying that is that surrounding every sodium ion that's positively charged, it's surrounded by chloride ions. Why? Because opposite charges attract.
Okay.
So it's these unlike charges and their attraction that holds ionically bonded compounds together. That's what holds this crystal together. And it's easy to break those bonds by adding water and dissolving the salt. That's how you break the bonds. You'd still have sodium chloride ions floating around in the solution, but they wouldn't be attached to one another because the salt has dissolved the crystal. Does that make sense? In the case of covalent bonds, you have equal sharing of outermost electrons, as is the case between two hydrogen atoms to form hydrogen gas, H sub 2, H2. In fact, this slide shows a bunch of different ionic bonds. Here's a single covalent bonds. Here's a single covalent bond, equal sharing of valence electrons. Hydrogen number 1 says, I'll share my valence electron with you. Hydrogen number 2, if you do the same, and it says, yes, I'll do it. And they both share, and we create H2. That's the chemical formula of hydrogen gas. In the case of water molecules, here's 2 water molecules, 2 hydrogens and an oxygen. Each hydrogen shares one of its valence electrons. It only has 1, so it shares its valence electron. And the oxygen says, I will share one of my valence with each of you hydrogens.
There's H.
That way, I've got now 8, 1, 2, 3, 4, 5, 6, 7, 8. And hydrogen has 2 in its first shell, which is the maximum. It's happy. We create water molecules. So it's equal sharing. Does that make sense? We denote the presence of a single covalent bond with a line. If we're sharing 2 pairs, we use an equal sign kind of thing. It's not really an equal sign, but it's 2 lines. 2 single covalents or a double covalent. Here's water. Here's the oxygen. Here's the single covalent bond between it and each of the hydrogens. Now, you might say, well, why is this angled the way it is? Right? Why isn't it straight out or whatever, like the 2 oxygens were? Well, that's a complicated, long lecture topic, but it's pertinent to our discussion of what a hydrogen bond is. Because what this is kind of meaning is that when you look at those shared electrons, oxygen, if you go back to this diagram, oxygen is a lot more electronegative is the term they use. It's a bigger element. It's got 8 plus charges in the nucleus, right? Each hydrogen only has 1, so it's like 8 times bigger. So these shared electrons, they are shared, but because of the 8 positive charges in the nucleus, it tends to exert a greater tug or pull on those shared electrons. The effect is to create a slight negative charge on the oxygen end. That's what this is showing. This is a water molecule. Here's oxygen, here's the 2 hydrogens. So you end up creating a slight positive charge on the oxygen end and a slight negative charge on the hydrogen ends. If that is created, which it is, then you can see how there could be an attraction between the slight negative charge of one water and the slight positive charge of an adjacent water, and that's what the hydrogen bonds here are denoting. These are weak bonds, much weaker than covalent or ionic, but nonetheless, they are important bonds. It's what holds water together. It's why water has a high surface tension. It's why water can exist in all 3 states simultaneously as a gas, a liquid, and a solid. It imparts lots of interesting properties to water. Hydrogen bonds do. Another molecule that you can see hydrogen bonds forming is in DNA. Here we're looking at a part of the DNA molecule. These are called nucleotides. They're the building blocks of DNA and RNA. And these things called these are bases, like adenine and thymine and cytosine and guanine. If you've ever heard of those are called nitrogenous bases. And at the very center of the double helix of a DNA molecule, what holds these bases together, the A, and the T, and the C, and the G together, are hydrogen bonds. They are individually quite weak, but collectively strong enough to hold that double helix together. So they're very important. And that's the extent to which you need to know those 3 kinds of bonds.
Okay.
How well do we have to know the carbohydrates, lipids, proteins, nucleic acids?
Okay, so with regard to the three or four major classes of organic molecules, okay? Those four classes are carbohydrates, proteins, lipids, and nucleic acids, as Sadie mentioned. What I think I would know is that with respect to carbohydrates, the simplest carbohydrate is called a monosaccharide, meaning single sugar. And there are different kinds of single sugars. This is the most common one that you should be familiar with. It's called glucose. Is a chemical formula of C6H12O6. And this is incorrect. This 6 should be a subscript, and the 12 should be a subscript, and the 6 should be a subscript of the O. They should not be superscripts. I don't know how that got in there, but do you know what I mean by subscript, superscript? Okay.
The positions, right?
I'm sorry?
Is it like the position of the 6?
Yeah, it should lie below here.
Yeah.
Down here, and down here, and down here. So the chemical formula of glucose is C6H12O6, and you can count up the 6 carbons and the 12 hydrogens and the 6 oxygens if you want. It's not critical that you memorize this chemistry or anything, but you should know that glucose is a monosaccharide. And this is called the straight chain form of the molecule. Glucose tends to prefer to wrap around itself and make what's called a ring. This is called a hexose ring, a 6-sided ring. There's 6 carbons, there's 12 hydrogens, and there's 6 oxygens in here. So you should know what a monosaccharide is, and you should know that glucose is one of the more common and more important ones. If you take 2 monosaccharides and you bond them together, what do you make?
Say it again.
If you take 2 monosaccharides and you bond them together,
Disaccharide.
you make a disaccharide.
Disaccharide.
Di meaning 2. So there's 2 sugars bonded together. Here's a mono, here's a di. What's this?
Poly.
Many, polysaccharide. What are some examples of disaccharides? Do you know any? You do, you just didn't know, you don't know. You don't know that sugar is a disaccharide, what you put in your coffee or tea or whatever, your cookie recipe. Sugar. Do you know any polysaccharides? Maybe you'll have them for dinner tonight. In what form? Maybe for lunch. Do you like toast? Do you like bread?
Yeah.
Do you like starch? Starch is a polysaccharide.
So
Do you like noodles? You know what's Sadie?
Are they like your carbs, basically?
Yeah, most of the time when we talk about carbs, we're talking. I mean, theoretically, it could be any of these, but most of the time when people say carbs, they're probably talking about di or poly. Yeah, you're right. It kind of depends, though. The term carb could refer to all 3 types.
Okay.
In terms of lipids or fats, the book introduces a couple different types of fats. It talks about triglycerides. It's probably the most common type of fat. And here's the chemical makeup of a triglyceride. What you need are 4 different components. You need 3 fatty acids, shown here in light blue or light yellow. And then this dark orange yellow is called glycerol. And the 3 fatty acids bond covalently to the glycerol to make a triglyceride. Now you've heard of saturated and unsaturated fats probably, right? What's the difference? Well, the difference lies in the fatty acid components of the molecule. If there is 1 or more double bonds anywhere here between the carbons in the light yellow fatty acid components of the fat, it would make that entire fat an unsaturated fat. Typically, unsaturated fats would be liquids at room temperature, like olive oil, safflower oil, canola oil. A lot of oils being liquids would be unsaturated. If we had all single covalent bonds between the carbons, then we call this whole fat a saturated fat because the carbons are saturated with the maximum number of hydrogens they can bind to. That's what that word comes from. Those are solids at room temperature, like lard, or like the fat we saw on the rat dissection. Remember, in some of the abdominal organs were covered with that yellow fat. That's saturated fats. Yeah. Those are the things that you don't want to be eating a lot of because they increase the risk of atherosclerosis and heart disease.
So that's the dust of the ribs.
Yeah, that's what you had last week, right?
Yeah.
I had wings on Sunday. I have to admit, I have a wicked wing recipe in my air fryer. It was great. So, you know, everything in moderation. You can have wings, you can have, you know, spare ribs. Just don't be going through the drive-through at Wendy's down here every week. That's not good. And get out, get some exercise, right? It's our sedentary lifestyle and our high saturated fat intake that contributes to such high heart disease in America.
So the $600 smoker, I should have just not bought that.
Take it back.
Yeah, right.
Okay.
That ain't gonna happen.
Another really important lipid you should be familiar with is called a phospholipid. Now, what is that? Well, let's take a look at the chemistry here. And you don't have to memorize the chemical formula or anything. That's not what I'm trying to get at. But if you look close, here's glycerol in dark orange. Here's 2 fatty acids. And then instead of a 3rd fatty acid like we had back here in our unsaturated fat, we have what's called a phosphate group and then a couple more carbons and a nitrogen. What that really is, if you try to, you can use a symbol to represent a phospholipid. This is what the book does. It uses this circle to represent this kind of part of the molecule, this lower half. This is called the hydrophilic head region of the molecule. And then here's our 2 fatty acid tails. Those are these 2 guys up on top. Those are those 2 tails. And they are hydrophobic. Why do I even bring this up? Because when you study cell membranes, which you did already, you learned about the phospholipid bilayer. Do you remember that? It's in chapter 3. You want me to pull it up to remind you or show you? Well, anyway, it's in chapter 3. Look it up. I can tell you what page it's on, in fact. Page 90, 89 and 90. I'll hold this up. There's a sketch of what's called the fluid mosaic model of the cell membrane. And those yellow structures are phospholipid molecules in a bilayer, in a 2-layer arrangement with the hydrophobic head, hydrophilic head regions facing out or in to the cell, and the hydrophobic tails are oriented in the very center of the bilayer where there's no water. Because hydrophobic means water fearing, hydrophilic means water loving. So this is an important type of lipid. So I think you should know what a phospholipid is. A steroid, you've heard of steroids before, right? A steroid is a member of the lipid family. And there's all different kinds of steroids. You've heard of the use of anabolic steroids in athletic competition like the Olympics. People use anabolic steroids so they can perform at higher capacity and win gold medals and get lucrative financial deals with Nike and all those companies, right? It boils down to the almighty dollar. That's what it boils down to. So steroids are fats, are lipids. Here's an example of a steroid, cholesterol. Most people have a negative connotation of cholesterol, but the fact is there's good and there's bad kinds. I'm not going to get into the detail of that now, but if you've ever heard of of HDLs and LDLs. Have you ever heard of that?
Mhm.
So HDLs, high density lipoproteins, HDLs, low density lipoproteins. It's the HDLs that are the good cholesterol and the LDLs are the bad cholesterol. So why do I bring up cholesterol? Well, because cholesterol can also be one of those structures found in the cell membrane, embedded within the bilayer. And it helps to affect the fluidity of the bilayer, actually. It affects the fluidity of the membrane, which in turn can influence the movement of materials across it. What they've discovered, interestingly enough, is that hibernating animals, like we're in the middle of winter now, right? So
Right.
woodchucks and chipmunks, they're hibernators. Scientific studies have shown that when animals that are hibernators enter winter, they change the cholesterol concentration in their cell membranes. It's less fluid, less leaky because of the lower temperature, because their metabolism is so low. It's interesting.
It keeps them from freezing.
Well, no, but it aids in normal cell function. I'll just leave it at that.
Okay.
In terms of proteins, what should I know about proteins? Well, you should know what the building blocks of proteins are. Do you know what they are?
Amino acids.
Right, amino acids. What is an amino acid? Well, an amino acid is a chemical that has what's called an amine group. So if you look up here on the slide, this N and bonded to the two hydrogens, this is called an amine group. This carbon double bonded to an oxygen bonded to an OH, this is called an acid or a carboxyl group. So all amino acids have an amine group and an acid group, as evidenced by the white, purple, and pink zones of 3 different amino acids. They all share that same chemistry. So what makes these 3 amino acids different from one another? If their amine groups are the same and their acid groups are the same, what's the difference? Well, look what's bonded to the central carbon here. It's called an R group. It's the different R groups that make the amino acids unique. So this particular amino acid called cysteine has a carbon and some hydrogens and a sulfur and a hydrogen. It's a pretty small little R group. But look at phenylalanine. It's got a ring here to it. It looks almost like a sugar, doesn't it? In fact, it could very well be a sugar. And so the 20 amino acids are unique from one another because there are 20 different R groups attached to that central carbon. When you take amino acids and you join them together, like we're doing here, so here's the one amino acid. We're just depicting the R group as R. This is not an element. This just means R group, 1 of 20. When we bond the 2 together, the acid group of 1 to the amine group of another, we create a peptide bond. Well, what kind of bond is this? Can anybody tell me?
Covalent.
Yeah, it's a single covalent bond.
Covalent bond,
Yeah, exactly. But this is what links those 2 amino acids to create what's called a dipeptide. And when you continue to do that repeatedly again and 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 again, 100 or 200 or 1,000 times, you'll eventually make a protein. There's different levels of organization within a protein. Here we see the individual amino acids linked together. We're depicting these as kind of like little beads, different colored beads linked together. But these actually fold on top of one another. There's added bonding going on. You can create different levels of structure. This is called the primary structure. This is called secondary. This is called tertiary. And this is called quaternary structure. As you go from top to bottom, the levels of organization get more complicated. But all molecules have a 3-dimensional conformation or shape. And that's best shown here if you look at the quaternary structure of the protein. And we'll be talking more about how the 3-dimensional shape of the molecule is really important when we get into enzymes and how enzymes work. But that's actually in chapter 4, I think. So you might be getting into that now. You should be getting into part of chapter 4 this week. In fact, they talk about enzyme catalyzed reactions. That enzyme has a particular region called the active site where the substrate fits. So the specificity of that active site is determined by the shape of the protein. So we kind of ran out of time, I think.
Yeah, but we covered it.
So the last thing is basically the nucleic acids, and you should know the building blocks of those are called nucleotides, and the book kind of talks a little bit about DNA, how these nucleotides are bonded together. And so just spend a few minutes maybe looking at that last few sections of chapter 2 slides.
Mhm.
This is talked in more detail in chapter 4, in the last part here where it describes replication of the DNA, and also how the DNA and RNA is used together to make proteins. So, any last minute questions? Doesn't take long to gobble up an hour.
I have a question.
Okay.
So should we be studying more of the power slides than the actual like chapter outlines? Like, cause mostly I just studied what we did Sunday during group study, and it was basically like, I have it right here. Like all matter is composed of, like, am I studying the wrong stuff? I
No,
guess
you're
that's my
not.
question. No? Okay.
Well,
I just want to make sure I'm,
if what I just spent the last 20 minutes talking about is totally foreign to you, you haven't been studying enough.
say it again?
If the last 20 minutes of what I was talking about you didn't study, then you're not studying enough.
Okay. I just want to make sure, because
Yeah,
like I said, I've been doing all of this stuff
yeah, good.
more than that, so now I know that.
Well, you
go over
wanna
the
know
slides and
what
make
your-
sure. I mean, a lot of it's familiar from chemistry, but.
yeah.
Okay, just wanted to double check. Thank you.
Okay, sure.
Yeah, so
Okay,
that's,
I have an appointment I need to run to. Any last minute questions? Okay, well, study hard. I'll see you tomorrow morning in lab. All right? Okay, thank you. Bye.